AT. We are going to have some quick notes on circles here for me being gone, and then after that you guys are going to have some practice and a progress check that you're going to do with the sub. So anyway, the notes on circles, if you were in 8th hour, we kind of did this first little bit kind of together. Still want you to watch it again because it'll kind of like reinforce what we talked about, and it was only the last couple minutes of class. If you're in 6th hour, we didn't talk about this at all. So for the first little bit, just kind of watch and try to like understand what's going on. So circle is basically, it's all the points that are the same distance from some center. Oh, I did not mean to do that. And so we have like a constant radius r. So like this distance from the center out to the edge, that would be r. This would be r, this would be r, this would be r. All the way around would be the same radius. So how do we come up with the equation of it? Well, if we take any point on the circle, then I can put the point here, I can put the point here, it does not matter where you put it, and you draw your radius out to it. So this would still be that same radius r. This point is going to be just some x comma y. It doesn't matter what it is. It could be 3, 5, it could be, or 3, 4, it really doesn't matter. But any point on there. And then from there, we could draw in this little triangle. Now, x is always the distance from the center along the x-axis, so this would be x. And y is always the distance up from the x-axis, so this would be y. And x and y are always going to be at right angles to each other. So I end up with this triangle here with 3 sides, and there is a theorem that relates those sides. And in class, I know at 8th hour, somebody shouted out Pythagorean theorem, which is great. And that is what we are going to do to relate these things. So for every circle, it's going to have a point xy on the edge. Doesn't matter where it is. The relationship between xy and the radius would be the Pythagorean theorem. So just x squared, a squared, plus y squared, b squared. So like this is my a side, this is my b, and this is my c. And again, a and b don't matter on the Pythagorean theorem as long as c is across from the 90. So x squared plus y squared equals c squared, or r squared. This is the equation of a circle. It is just the Pythagorean theorem. A squared plus b squared equals c squared. So when we see this, anytime it's in this form, it will always make a circle. Now this particular circle is centered at 0, 0. So what happens when we want to move it around? So like I don't want it to be at 0, 0. So, for example, let's say I had like x minus 3 squared. Well, if you think about for parabolas, for absolute value, all of those things, this would go to the right 3. And that is still going to be true for circles. And for every time we had the y's, that one's a little bit tricky. So like if I do y plus 2 squared equals, let's say, 4. So this one's going to be a little tricky because all of our y's on parabolas would go up that number. So you might think this would go up 2. This one will actually go down 2. But before you freak out, I'm going to show you a different parabola really quick. So let's say we had y equals, I'm going to stick with the x minus 3 squared, but I'm going to put a plus 2 on this side. Actually, I'm going to put a minus 2 because then it'll match more with this. So this would go right 3, just like it does here. And this would go down 2. Okay. But what would happen if I move that 2 to the other side of the equation before trying to evaluate that? So let's say I move the 2 over and put it next to the y. And then I'm going to rewrite this as y plus 2 in parentheses equals x minus 3 squared. This would still go right 3, but that plus 2, because these two equations are the same, okay, that plus 2 has to still do the same thing. So when it's next to the y, it doesn't actually move us up 2, this is going to go down 2. And another way of thinking about that is, what do we have to do to get back to the center? So what value of x here would make that 3 cancel out? Well, 3 minus 3 would be 0. Okay, so a positive 3. What value of y would make this 2 go away? Well, it would be negative 2, or down 2. So one more example before we go to the note side of things, just to kind of clear this up. So let's say it was like x minus 5 squared plus y minus 8 squared equals 9. And then we'll get to these numbers here in a second. So just like it is for parabolas, this will go right 5. But now because it's next to the y, it has to go the opposite. So this will go up 8 instead of down 8. And then the question becomes, how big is the circle? So in the equation here, these are always r squared. So my radius is not 4, it's something squared there. So that means that the radius would be 2, because 2 squared equals 4. So in this case, what number squared gives you 9? That would be 3 squared. So our radius is 3. All right, so that's kind of background of what circles are. I wanted to kind of do all that before having you put them in the notes. So if you haven't taken out your note packet, take it out. And we're on page 23. So on page 23, we are now going to make this a little bit more formal notes. Again, 8th hour, you've already done that before, but there's a couple examples probably helped solidify some things. And sometimes it's good to watch it twice. In 6th hour, if this is the first time you've seen it, if all of that went a little fast, feel free to rewind it and watch it again, because that's the why of what these notes are. So circles, it's up to you if you want to write a definition. The most accurate definition, although most of you guys know what a circle is a set of points, technically equidistant, but I'm just going to say the same distance from the center. And then I'm going to write 2 equations of the circle. So the one that is at 0, 0 would just be x squared plus y squared equals r squared. And that, again, is the Pythagorean theorem. Pythagorean theorem, and like the idea of a squared plus b squared equals c squared. But if this was shifted somewhere, so this one would have a center of 0, 0. So in general, if we want to slide this circle somewhere else, because if you look at all of your circles, there's none of them. Well, number 1 down here is, but all the other ones are shifted somewhere else. So if we want to shift somewhere, a lot of times when people write this out, they'll write x minus h squared, and h can be any number, like 5, plus y minus k squared equals r squared. So when someone says, what's the standard form of a circle, generally we're talking about this one. Now, this would go right h, and then up k, so my center would be at h comma k. But just think about them being kind of opposite for both of them. And then the radius is whatever this number, kind of the square root of what it equals, but radius equals r. All right, the h and k, that part looks weird. They're not as hard as all of that, okay? So what we want to do is just figure out all of our stuff for our circles and then kind of think just Pythagorean theorem for the most part. So the first thing we want to find out is where's the center. So this one's got a center, and it's at 1, 2. And then our radius is our distance from the center to the edge. So I can go any 1, 2, 3, 4. So it's 4 to the right, or you can go up 1, 2, 3, 4, 4 up. 1, 2, 3, 4 down, 4 left. If one of them didn't match 4, then it wouldn't be a circle, but the radius had better be 4. All right, so our equation is kind of x squared plus y squared equals some radius squared. I'm putting parentheses around them because we got to slide it. So we got to go from 0, we're going right 1, up 2. So to go right 1, I'm going to put a minus 1 in with the x. To go up 2, I'm going to put a minus 2 in with the y. And then this would equal our radius squared. So radius was 4, so 4 squared is 16. I'm okay with 4 squared, but 16 is the better answer of the two. For now, if you want to graph it on Desmos and make sure it matches up, that's fine. You don't have to do anything weird. You would just type this entire thing in here. Let me show you what it would look like really quick, just so that you know. All right, so here it is on Desmos, especially the 16. It doesn't show you the center, so if you ever wanted to plot the center, you would have to just do 1, 2 to see that it's actually in the middle. But if I forget to square it and I make it equal to 4, you can see that that's a much too small of a circle. So you write it as 4 squared. That'll work, but 16 is kind of the idea. And then if you're on Desmos and you want to mess around with it to see what happens if you put like a +2 instead of a -2, you see how it's shifted down by 2. So I think the Y is probably the trickiest one, just because for all the problems we did in the last couple days, that up or down matched the sign, but that's because it wasn't next to Y. All right, the second one is surprisingly hard for this problem. I mean, just because there's no grid, and you're not 100% sure exactly where the center is. So, like, there's a couple options you could do. So, like, if I were to draw like a line across that way, and then a line across from here down to here. I don't know why I missed there. Come on, move over. There we go. That intersection would be our center of them. So we got right 3 down 1, so 3, -1. Another way you could do this is you can figure out how far left this goes. So this is here at -2. And this goes right to 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. So the number between -2 and 8, I mean, you could just average them. 8 plus -2 divided by 2. So 6 over 2, which is 3. There's a lot of ways to figure out that 3 is the x and -1 is the y. Another thing you can do is you can just count in. So as you go left, you go to the right. So you go left, on the left, on the right, on the left, on the right. You can eyeball it, I guess, but like you gotta figure out where that center is. So 3, -1. And then my radius is just how far to the edge. So again, if I'm here at 3, 1, here's 1, 2, 3, 4, 5. So my radius is 5. So my equation, x squared plus y squared equals my radius squared. So right off the bat, I'm going to put 25 because that's my radius squared. Now, center of 3, I want to go right 3, so -3. I want to go down 1, so +1. So center is right 3, down 1. And you can do it from the graph, you could do it from the actual center and the signs on that, but that's it. All right, I'm going to do, I think, these 3 and then send you on practice time. All right, so going the other way, from equation to graph. If there's no numbers in here, there's no shifting left, right, up and down, it's just going to be 0, 0. And our radius, some of you are going to say 4. It's not 4, it's 2 squared is 4. So what number squared? So you have to do the square root of 4. Square root of 4 gives us 2. That's our radius. Now it asks you for domain and range too. So we sketch the graph, then do the domain and range. Okay. So we're going to go out 2 in each direction. So 2, 2, 2, 2. And then just do your best to make it not look like a potato. And then domain and range are actually really easy for circles. It's always going to be, you're not going to have any infinities because I've never seen an infinite circle before. So you just figure out how far left does the graph get to, so it doesn't go left of that point, and how far right does it get to. It doesn't go right at that point. So it sure looks like -2 to 2. And the domain is, or the radius is 2, so it will get to 2. And then the range is going to be a little bit boring because the range, how far down does the graph go? Well, it goes down to -2, and it goes up to +2. So my range is going to be exactly the same thing. Now, they're only going to be the same if you are at 0, 0. The second you start sliding around, then things go off. So our second one, the +3 would make us go left 3. So put our center at -3. And then there is no up or down, right? So just left 3. So -3, 0. And then our radius is going to be the square root of 16 or 4, because 4 squared is 16. So for our graph, we just go 1, 2, 3, 4 to the right, 1, 2, 3, 4 up, 1, 2, 3, 4 left, 1, 2, 3, 4 down, and then do your best to connect the dots. So try to actually touch the dots instead of just going next to them like I do, but it's easier on paper than it is on the computer. All right, so our domain, farthest left, farthest right. So right over here would be the right there would be the farthest left. You just count it if you want. You can use your center and your radius to figure it out. So we're at -3 and we go 4 to the left of that, but it's just easy to count too. So here's -1, 2, 3, 4, 5, 6, 7. So -7 on the left, and then it goes right to 1. But then the range is going to be different because it goes down 4 and up 4 from 0, right? So if I go with 0 and then a radius of 4 both ways, the lowest is going to be -4 and the highest is going to be 4. All right, so I want you to pause the video, try 3. When you're done with it, I want you to press play and then start it. And similar, if you need to go back and rewatch any of these, the nice thing about being on video, you can definitely rewatch it. If you weren't paying attention in class, it's a little bit tricky to say, can you redo that whole problem for me? But now you can. So pause the video, try 3. All right, hoping that you did so. If you didn't, then whatever, we're going to do 3. So this would go right 4, because it's always opposite, and this would go down 2. So right 4, down 2, our center would be at 4, -2. And then our radius would be 3 squared, which is 9, so radius equals 3, or the square root of 9 equals 3. However you figure out the radius is 3 and not 9, we go 3 in each direction. So 1, 2, 3 to the right, 3 up, 3 left, 3 down, connect the dots. If you miscount them, it won't look like a circle. Not that my circles look like circles anyway. All right, we said the radius is 3, so just put 3 here. And then for our domain, especially if you put dots, it really makes it easy. So the farthest left would be this dot here. The farthest right would be that dot. So the one on the left is at 1. The one on the right is at 2, 3, 4, 5, 6, 7. So that's at 7. This is at 1. So from 1 to 7. And then my range would go to the bottom. So right here's the lowest this graph gets. It doesn't go down below that red line. So that's down 1, 2, 3, 4, 5. So -5. And then it goes up to 1. All right, so what I want you to do next is the sub should have this practice guide here. And so it's got some of those fog, f of g, just kind of things we did at the beginning. We did it through points, some domain and range work. And then I think people have a little bit more fun with these, at least I do. So sketch some stuff, some of the stuff from before, absolute value, all of the parent functions that we have. And then there's a little circle practice at the end of it. So I want you to do this. When you're done with it, you can check your answers on Schoology in the subfolder. And then there's some quizzes practices in there as well. So let me show you where that is really quick. So in Schoology, in our classes, there is a 919 subfolder. You click on this guy. At least there's one quizzes practice on here. I might add another one in there in a second, but this is a circles quizzes practice. But I also have the key for this. So I'm not sure if I'm going to change that up or not. So check your answers on the key, do the quizzes practice, and then tell the sub that you're ready for the progress check. If you have any time left beyond that, then you have a study hall. All right, but you got to finish your progress check before I would say that you have practice time or work time. All right, hopefully that all makes sense. Send me an email if it does not.